Hey guys, it's Mr. Regan. Today we're going to look at exponential growth and exponential decay. We'll start out with the exponential growth model. So the formula we're going to use is y equals a times the quantity, 1 plus r to the t power. A is going to be the initial amount, whatever we're starting with. R is going to be our growth rate, and it's going to be in a percent, but when we put it in our equation, we're going to use a decimal form. And then time is the amount of time, or the time period. We also have a name for 1 plus r, what's in the parentheses. We call that our growth factor. The exponential growth model looks like this, where it starts off kind of slow and it increases sharply. And that's, when things grow exponentially, they shoot up real fast. All right, let's take a look at a problem. The Horsham Surf Shop opened in 2005. They made a profit of $3,000 the first year in business. Business was good, and the surf shop made a steady increase in their yearly profit of 6% each year for the next 5 years. Write a function that models the profit in dollars after 5 years, and then use the function to find out what the profit was after 5 years. All right, so I'm going to use my exponential growth model, y equals a times the quantity 1 plus r to the t power. A is that initial amount, and that's going to be our $3,000. That's what we started out with. That was the first profit. In the parentheses, 1 plus r is our growth rate, and that was 6%, but we're going to use a decimal, 0.06. And then to the t power, t is the number of years, and that was 5 years. I'm going to clean this up a little bit. Inside the parentheses, I can add 1 and 0.06, and I get 1.06. Be careful with that. I've seen kids make mistakes there just by adding the 1 and the decimal, and then your answer is going to be wrong after that, and that's something that shouldn't be that difficult to do. All right, to the 5th power. All right, so now I want to use this and find out what the profit was after 5 years. So I would first do 1.06 to the 5th power. We would then multiply that by 3,000, and then my answer ends up to be 4,014.68. I round that to the hundredths place because we're talking about money. So my profit after 5 years is $4,014.68, which seems to make sense because it should be increasing. It's a growth. It started at a $3,000 the first year and went up each year, and now it's up to over $4,000 in the 5th year. All right, exponential decay model. All right, this formula is very similar. Y equals a times the quantity 1 minus r. Instead of 1 plus r for growth, it's 1 minus r for decay, to the t power. A, once again, is our initial amount. R, this time, is going to be our decay rate, because now we're not growing, we're decaying. And t is still our time period. And this 1 minus r will be the decay factor. All right, so this decay model, now we're talking about things decreasing. So it's starting up here, it's decreasing sharply, and then it levels off. So it's exponential decay, it's decreasing. All right, let's look at a problem. The Keith Valley Math Department has to buy new calculators every few years because calculators either break or get lost. Keith Valley had 500 calculators in the beginning of 2010, and the calculators break or get lost at a rate of 4% per year. Write a function that models how many calculators Keith Valley had in 2014, and then find out how many calculators Keith Valley had in 2014. All right, so we have our y equals a times 1 minus r to the t power, our decay factor model, and a, that's our initial amount. We started with 500 calculators. 1 minus r is that decay rate, 4%, but we're putting it in as a decimal, 0.04. And t is our time, and we want to know 2014. So if it started in 2010 and went to 2014, that's 4 years. I'll clean that up a little bit. Inside the parentheses, once again, be careful. Make a mistake here, your answer is going to be wrong. 1 minus 0.04 is 0.96 to the 4th power. Right, now I want to figure out what my answer is, so I do this part first. 0.96 to the 4th power always exponents before multiplying. Multiply that by 500, and I get y equals 424.7 if I round it to the tenths place. Alright, now this is where we get hung up a little bit. Normally, we're talking about calculators, so I really want to round this to a whole number. I don't want a 0.7 of a calculator. So now I'm in the dilemma. Do I round it up because of 0.7, or do I round it down because you really can't have more than 424 if you only have 0.7 of a calculator? So at this point, I would accept 424 calculators because I understand where you're coming from. I would also accept 425 because I understand the math and rounding up. So for me, I'm accepting either answer as long as you can explain why you did each of these, whatever one you chose. Alright, so that's the exponential growth model and the exponential decay model. Good luck, guys.